So let's talk about what concept called total probability. Um, let's say I'm interested in what's the probability that somebody's wearing a hat. Well, I can just break that. Of course, I can just count here, right? Like 1, 2, 3, 4 out of 16 is 1/4. That's what we did before. Uh, but for whatever reason, let's say I don't actually know the total number of hats in the population, but I do know what the probabilities are of having a hat in each of these subpopulations. So among the pink people, the black people, and the gray people, I know, for example, 1 out of 3 gray people is wearing a hat, 2 out of however many black people, and 1 out of every of the 5 pink people are wearing a hat. So how can then I calculate the total number of people wearing a hat? Well, if we were counting, it's pretty straightforward. So the pink, gray, and black groups are mutual. Like if somebody are mutually exclusive, so if somebody is pink, they can't be gray. So I know that I won't be double counting anyone. So all I need to do is just take the total number of people who are pink and wearing hats, add the number of people who are gray and wearing hats, and the number of people who are black and wearing hats. That's it. So I just need to add those numbers together. So when I'm talking about probabilities, again, it's the same as counting. I just need to divide by the total denominator, which in this case is, I think, like 16 or something. So now we can cast these as probabilities instead of as counts, but it's the exact same concept. Um, and we can use the notation that we were using before. So instead of writing as pink person with a hat, we usually say hat and they are pink. So written like that. And of course, those using the multiplication rule, we can express those and probabilities as the product of a conditional probability, the probability in a subpopulation with the marginal probability. So that's we could write it like that. And this thing here is what we call the law of total probability. It's just a way of breaking up a probability, a marginal probability, expressing it as the conditional probability of that thing in different subpopulations times the basically like the number of people that are in those subpopulations. All of it comes down to just exactly this. It's just counting up how many hats there are as the sum of hats in the different subpopulations. This is all just kind of like accounting. So that's an important thing. I think we'll see examples of that in the future, certainly.